we're going to evaluate the definite integral from 0 to pi over 2 of 1 divided by 1 plus tangent of x. Now we are going to need two results to evaluate this integral. The first result is the integral from 0 to a of f of x equals to the integral from 0 to a of f of a minus x. We'll derive this result shortly. The second result we're going to need is cotangent of x equals to tangent of pi over 2 minus x. This is just a standard trig identity. Let's derive result number 1. We'll start with the integral on the right, 0 to a f of a minus x dx. Let's substitute by using u equal to a minus x. Du equals minus dx minus du equals to dx. Now x is between 0 and a. In that order, we start at 0, go to a. When x equals 0, u equals a, and when x equals to a, u is going to be 0. So the integral in variable u is going to run from a to 0. And now let's write this integral in variable u. It is going to run from a to 0. F of u times minus du, which is minus the integral from a to 0 of f of u du. To reverse the order of integration, we have to introduce a minus sign since we have a minus in front. This is the integral from 0 to a f of u du, and u is what we call a dummy variable. We can call it whatever we want. We can call it y or z or t or x. So that's the same as the integral from 0 to a f of x dx. And that verifies result number 1. Now let's return to the integral, the definite integral from 0 to pi over 2 of 1 divided by 1 plus tangent of x. If we can use substitution here, we can use substitution, but the resulting integral will be called an improper integral. Since we have not covered that yet, that's not the way to go. We're going to use result number 1 here with a being pi over 2. So using the fact that a is equal to pi over 2, this is equal to integral from 0 to pi over 2 f of pi over 2 minus x. The only x we have here is in the tangent, so this is 1 plus tangent of pi over 2 minus x. And now, by using result number 2, tangent of pi over 2 minus x is cotangent. So this is 1 divided by 1 plus cotangent of x. You may say, well, this new integral in this form is no easier than the original one. We have to do the next step. The next step is to multiply everything by tangent over tangent. So we multiply this by tan x divided by tan x. And this is equal to the integral from 0 to pi over 2. In the numerator we have tangent of x. 1 times tangent is tangent of x. Cotangent of x times tangent of x is 1 dx. So what we just showed is this. The original integral that we started with from 0 to pi over 2 was 1 divided by 1 plus tangent of x. And this integral actually equals to the integral from 0 to pi over 2 of tangent x divided by 1 plus tangent of x. Again, you may say, well, these are equally as difficult to evaluate, but now let's look at this result. Twice the integral that we want, twice the integral from 0 to pi over 2, 1 divided by 1 plus tangent x dx can now be written as the integral plus itself. So the first one we'll write as 0 to pi over 2, 1 divided by 1 plus tangent x. And the second version is going to be integral from 0 to pi over 2 tangent x divided by 1 plus tangent x. Well, let's add these two up. You can see that they have common denominator. We have twice the integral from 0 to pi over 2 of 1 divided by 1 plus tangent of x is now equal to the integral from 0 to pi over 2, 1 plus tangent x divided by 1 plus tangent x. Well, of course, that's 1. That's just the integral from 0 to pi over 2 of 1 dx, which is equal to x evaluated from 0 to pi over 2, and that's equal to pi over 2. And now we can finish this problem. We just showed that twice the integral from 0 to pi over 2 of 1 divided by 1 plus tangent of x is equal to pi over 2. Therefore, the integral that we want, the integral from 0 to pi over 2, 1 divided by 1 plus tan x, is equal to pi over 4. And that's the answer. For more